Good afternoon everyone and welcome to my YouTube channel. So here we are going to be proving irrational numbers. So we are going to be proving by the method of contradiction. So using the method of contradiction, we'll be able to prove. So what we have, let's say for example, you have the square root of 2. You have to prove this one to be irrational. So the first approach is we are proving using the method of contradiction, meaning to say we are going to say, let's say the square root of 2 is a rational number. What does that mean? So meaning to say, if it is a rational number, it can be expressed in the form a over b, where b cannot be equal to 0, as that would make your equation undefined. And the other condition is that a and b should not have any common factor. Like for example, we shouldn't have a situation whereby a has got a 2, even b has got a 2. We don't want that. Or if let's say your a and b have got, let's say, a 3 and b or a 3, this means to say already, this means that it is not a rational number. A rational number does not have common factors. So therefore we are going to prove using the method of contradiction. If two numbers have got a common factor or a common number, it means to say they are not rational numbers. So let's begin our working. So this is how we answer. So these statements are very important and they are part of answering. So we are going to say, suppose square root of 2 is a rational number. So is a rational number. What does that mean? It means that this number can be expressed in the form a over b. It can be expressed in the form a over b, where b should not be equal to 0 and a and b do not have common factors. The other condition is that both a and b should be members of integers. So that's our symbol for integer, z, meaning to say a and b can be negative or positive. Let's say -1, -5, whatever. So it means to say they must be members of integers. So now, with that considered, we are going to say, after writing that statement, we can be able to equate the square root of 2 should be equal to a over b. So we are able to do this because our assumption is saying that they are rational numbers, meaning to say square root of 2 is a rational number, meaning to say it can be expressed in the form a over b. So at this moment, we are going to square both sides. So squaring both sides, we are going to do this so that we get rid of the square root. So we have this, we find the square of that. Then what we are going to have is a 2 should be equal to, this 2 can be distributed, so it is the same as a squared over our b squared, like that. Then from there, we can cross multiply. So we are going to have our 2b squared should be equal to our a squared. So already, as you can see, we are saying that this can also be the same as a squared should be equal to 2b squared. So we are saying that a and b are equal if you add a 2 here. So meaning to say a has got a factor of, a has a factor of 2. Like for example, let's say we are looking at two numbers such as, let's say we have 8 here, then we have 2 times the 4. So in the other context, it could be 8 should be equal to 2 times the x. So you will realize to say 2 can enter into 8. So as long as there is a number outside there, you will realize to say 2 times 4 is 8. So that means to say, as long as you have a number that is outside a certain variable, it means to say it's a common factor. So if you see a squared should be equal to 2b squared, it means that a has a factor of 2. So yeah, so our a squared has got a factor of 2. Now if the square has got a factor of 2, it means that even our a square, even our a must also have a factor of 2. If the square of this has got a factor of this, even just the singular should have a factor of that. If that's the way it is, remember what we did. So if we said that 8 should be equal to our 2 times 4, this is still the same if you say 8 should be equal to 2 times x. Because if you divide over 2, you will find that your x will be equal to 4, which was this number. So therefore, we are going to say, therefore, a can be written as a should be equal to 2 times some constant k, where we know that our k must be an element of integers. So the integers, the negatives and the positives. That does not include fractions. So therefore, we have our a squared should be equal to 2 b squared, like that. So now what we are going to do is we are going to substitute. So this is our equation here. And we know that our a is equal to 2k. So now we want to see whether or not even b has got a number 2. So now we are going to replace. So where there is a, we put 2k. So we are going to have our 2k. Then we put a squared should be equal to 2b squared, like that. So our 2 squared is equal to, we can distribute this 2. So this is the same as 2 squared. Then we have k squared should be equal to, we have 2b squared, like that. So our 2 squared gives us 4k squared should be equal to, we have a 2b squared. Then we divide over 2, we divide over 2, like that. So this is giving us a 2k squared should be equal to b squared, like that. So what this means is that we are saying that b squared has a factor of 2, has a factor of 2. That means that even that's the singular b also has a factor of 2, like that. Therefore, remember, your a and b have got common factors of 2. That is why I was saying that a over b should not have any number in common. So in this case, it's a 2 and a 2. So if they have that number in common, you can be able to conclude to say, so we can conclude, therefore, a and b has a common factor of 2. So 2 is common, which is contrary to our assumption. We said that if it is a rational number, they should not have any common number. Then we are going to say, hence, we can conclude that the square root of 2 is irrational. As long as it has got common factors, it means to say it is not a rational number. Therefore, if it's not rational, it is irrational. So that is how we go about that on type 1. Thank you very much for watching. Hope you would like, subscribe, and share for more.